Yes, good morning, good morning, good morning, good morning. I hope all are fine. Yes, yes, all fine. Okay. So, what about examination? Done all the questions in exam? Yes, yes, I'm good. I'm good. Always fine. Hmm. Sir, we have error this week or not? Yes, error will be there. Now we will complete today. Error today will have. Okay. Yes. Okay. So, any other doubt? Any doubt? Any problem? You can ask first if any problem is there. Okay, no problem. Very good. All things clear? Everything is clear till now, whatever we have written, whatever discussed? Yes, whatever discussed. Okay. Okay, so now, so last class we finished up to dimensions. Yes? Okay, it was over now. Okay, so now we have to write the unit conversion. Okay, so you can write unit conversion. Okay, here you can write this heading unit conversion. Okay, means using the dimensions basically we can convert the units. Okay, using dimensions we can convert units. Okay, and we need to learn this thing without dimension also, because a lot of time we have to use. If I ask one, what is the density of water? Yes, density of water. If I ask what is the density of water, I'm asking value here. Okay, yes, you can say, sir, 1 gram per ml or 1 gram per, okay, 1 gram per cc. Okay, so everyone knows density of water is nothing but 1 gram per cc here. Okay, yes, someone is saying 1000 also. Yes, 1000 also we can say. Okay, basically if I ask that weight of, okay, that weight of this okay, bottle right now, okay, is 1, weight of this bottle is 1. Is this meaningful here? Yes, you will say, okay, it should be that 1 kg. Okay, yes, you have to tell the unit. Someone can say this thing is the 1000 kg also. I mean, 1000 gram, I can say. Yes, if I ask that here too, okay, like from right now from my position to Bijawada, okay, that bench circle, I can say it is around, okay, I say around 15. From my position to bench circle is right now 15. But you will ask, what 15? 15 feet, 15 meter, 15 centimeter, 15 light years, okay, 15 parsec. Yes, what we can say here? You will say 15 kilometer basically. Okay, or someone can say this one as the 15. Yes, 15,000 meter also. Someone can say this one h 150,000 centimeter also. Someone can say this one roughly 1 meter is having how many? Approximately 3 feet. I can say 3 point. Okay, something. If I say roughly 3, someone can say 45,000 pen drive. Okay. So basically, till I don't tell this thing, okay, then your magnitude, this value that you are writing here, that is not meaningful. Okay, so you need to tell about the unit. That is the significance of unit. Okay, means any of the given quantity. Okay, whenever you are writing, along with the magnitude, along with that value you are writing, you need to write always the. You have to specify all the time unit. Without unit, that given measurement will not be proper. Without unit, measurement will be proper or not proper? It will not be proper. Okay, so we need to learn how we can convert kilometer to meter to centimeter. This is a very simple conversions that we know. Okay, so we can write here whenever you have to measure anything, because we know physical quantities are basically which can be measured as well as quantified. So we can say first we need to put that value, we need to put that magnitude. Along with the magnitude, if I just say 10, 20, 30, 40, that is not enough. We need to tell about the unit also. So we can say n into u. Okay, now and you have to write, means n is the your magnitude, u is the unit. Now if it's okay, if I say mass of this one is 1 kg, now if you express in your any of the quantity, any of the unit, means that whatever the mass will remain same or it will change. If I express this thing in the different set of units, mass will change or will not change. Like distance from here to bench circle will remain same. Okay, values might be different in different units. The distance remains same. Is overall we can say this thing is going to be constant, or we can say n proportional to 1 by u. What is the meaning of this thing? Here you can say that when we are going from meter to kilometer means we are going for higher units. And when you are going for meter to kilometer for higher units, means that value, that magnitude is decreased. When you are going for meter to centimeter, when we are going meter to centimeter, it means we are going for what? Meter to centimeter, we are going for lower. So this value is increased. Means when you will go for higher unit, value will be reduced. When we'll go for lower unit, value will be increased. Is visible na? Means yes, okay. No voice. Yes, visible na? Okay, means okay. Now, so what I'm saying here basically in this one, that whenever we will change the units, okay, whenever you will change the units, what changes will happen basically? Whenever we are going to change the units, okay, what changes will happen? Okay, everyone knows, okay, that if we are going for here, we can say kg to gram. Kg to gram is the smaller units, that magnitude is going to be increased. Means that relation between n and u. What is the relation between n and u? Unit lesser, number will be, magnitude is going to be more. So we got this relation that n proportional to 1 by u, and that we have written also in the next slide, n proportional to 1 by u is if unit is less, then we can say here, okay, magnitude is going to be more. Okay, now we can write like this also, that here n1 u1 equal to, we can say n2 u2. n1 u1 equal to how much? n2 u2. Yes, is it clear here? n1 u1 equal to n2 u2. Okay, now using this we have to find, so basically we can say n2 that okay will be equal to n1 u1 by u2, or we can say here n1 u1 by u2. Okay, we'll use this thing. This is the one formula that we have to use for the unit conversion. Okay, but before this we will learn how we can do without unit conversion, means without using this formula, how we can do the conversion. Like if I say density of water, then everyone knows 1 gram per cc. Okay, 1 gram per centimeter cube. Cc means basically centimeter cube. Okay, and just now someone said 1000 also. So let's see what is correct here, 1 gram per cc or 1000. Okay, now we can write here that if okay, if I ask, then you can say, sir, 1 kg is 1000 gram. I hope everyone is clear. 1 meter is your 100 centimeter. So I can say here in this one, 1 centimeter cube will be how much? 1 centimeter cube. Yes, you can say 1 centimeter cube will be how much? 10 power minus 6 meter cube. I hope this thing is clear, because 1 centimeter will be how much? 10 power minus 2 minus 6. Okay, so directly we can write here 1 gram. 1 gram, how to, okay, this one is written in which system? CGS or MKS? If you remember, three things are there. One is the your SI, or we can say MKS, meter kilogram second. Second system we can say CGS, centimeter, gram, second. And third one we can say foot, pound, second, FPS. That FPS system we don't use here. FPS is there. We use FPS or we don't use? We don't use generally. So CGS, this one is in the CGS system. How to get this one into the MKS? So you can say 1 kg will be 10 power minus 3 gram divided by centimeter cube. Centimeter cube we have written 10 power minus 6 meter cube. So now you can say kg meter I got. If you find this will be 10 power 3 kg per meter cube. So you have to remember the density of water is this also as well as this also. So here I don't need this formula actually. Without formula we have converted. Can we go for next question? Yes? This slide is okay na? Okay, so now I will go for next slide. Okay, suppose I will tell some 3-4 questions which we have to use generally. Okay, like if I say specific heat of water, do you remember specific heat of water? Yes, what is the specific heat of water? Do you remember? Yes. Yes, and proportional to 1 by u or u proportional to 1 by means. Yes, this is okay here. Arrow up, okay. I placed arrow wrong. Yes. 1, okay. So you know a specific heat of, okay, a specific heat that you can, okay, you can change, okay. Here arrow I placed wrong, okay. In this one, u increases and decreases. So now we can see here that a specific heat of water, that is the 1 calorie per gram degree Celsius. Anyone remember this value in the SI system? In SI, what will be the value specific heat of water? Do you remember? Anyone here? Yes. 20. Next. Tell the value, okay? Don't say yes, sir. Okay. What is the value in the SI? Priyanka is saying 4.2. Anyone else? Gagandeep is saying 2. Someone else? Okay, Aditya is saying, Aditya answer is correct. I will not tell, okay, what Aditya is saying, but Aditya is correct. Next one, only one person told correct answer. Only 1% till now. So many answers I have received, so many messages I got. Only 1% told correct value. So basically, specific heat of water so many times we'll use, okay. Second answer correct, okay. I think now you have searched on Google. Yes. Now 2 people gave correct answer. Listen. So what we can say, we have to use SI as well as CGS. Both system we have to use. So first, okay, how we can convert? You can see if I say 1 calorie, so 1 calorie equal to how many joules? 4.2 joule. Okay, 1 calorie is 4.2 joule. You can remember as of now. Okay. So we can say 4.2 joule divided by gram. Basically, we know 10 power minus 3 kg. And if this is 10 power minus 3 kg, you can take upside. So answer will be here 4.2 into 10 power 3 joule per kg. That one you can write as 4200 joule per kg. Okay, 4200 joule per kg. Yes. So you have to remember that this is the 1 calorie as well as 4200 joule per kg. Okay. So can we do these simple conversions in which we don't need any of the formula? Is it clear? Okay. Yes. Now we'll go sometimes, okay, using that formula that I have told na N2 equal to. How we will solve, okay. Sir, do we need to convert degree Celsius to Kelvin? No. Okay. Right now, not required. Okay, here degree means this one I correct degree Celsius. Okay. Later on, I will tell that degree Celsius and Kelvin temperature change will be same. Okay. Right now, no need. Okay. So now we can see. Suppose if I give you one more here, that LF value is 80 calorie per gram. Okay. 80 calorie per gram, and this one you have to convert. So you can say 80 calorie will be 4.2 joule. Divided by, we can read gram will be 10 power minus 3 kg. So you can solve this one whenever you have to use. So 80 into 4.2 into 10 power 3 joule per kg. Okay. Because sometimes we have to use the SI units, sometimes we have to use the CGS unit. So both convergence. However, this thing is very, very simple. I know this is the nothing here, but okay, if I don't tell, later on people do mistakes in this thing only. They never do mistakes in the physics. They always do mistakes in the calculation part. Okay, so can we do this conversion here? Like for LF I have told 80 calorie per gram, then we have done calorie as 4.2 joule, and this one we have written 10 power minus 3 kg. Yes? Okay, so now I will tell sometimes using formula how we can convert. If this is a very easy calculation, very easy convergence, we can do without formula. Okay. Now, if we say what are the 1 joule in CGS, 1 joule in CGS, 1 joule in CGS, do you remember? 10 power 7 arg, okay, 10 power 7 arg. How we will prove 1 joule? Joule is basically your SI and arg is the CGS. So what the relation between SI and CGS? Now we need to prove. Okay, so I will prove here. So I can write now, okay, 1 joule I need to convert into your arg. Okay, arg means basically your CGS, we can say, okay, in the CGS system. So now we can see in the CGS system we need to convert this thing. So I can write, okay, this is the CGS. Okay, here I can write, and this is the your SI system. So we can write N2 equal to, we need to write N1 U1 divided by U2. Okay. Now in this one, what are the method basically? Whatever the quantity you want to change, you want to, okay, change the unit here, you will always write dimension of that N1. Now U1 means dimension of that. We are writing basically energy. And energy dimension is what? M L2T minus 2. Okay. And here we can use first. Okay. What is the meaning of this one? U1 means first, okay, first unit, first system, okay, first unit and second unit. In this case, we can say second unit we can write here. For the energy, again, we can write ML2T minus 2, here 2, here 2, here 2, okay. So U1 means first unit, U2 means second unit. In this question, if I say, what is the first unit? First unit is SI, second unit is CGS, okay. After doing this thing, what we can write here, you can write like this also, N1, M1 by M2, mass together, L together, L1 by L2 whole square, and here we get T1 by T2 power minus 2, okay. Again here, 1 represents first unit, first, okay, set of unit, 2 represents second set of unit, 2 represents second set of unit, clear? What are the first set of unit here? First set of unit is SI, second set of unit is CGS. Now we can write N1. What is this N1 value? That is the 1, okay, 1 joule. And 1 joule equal to how many arg? Okay, here what arg will be there that we don't know, okay. Don't say that sir, this is the 0 arg, okay. Here some okay, blank space is there that you need to fill. 1 joule equal to how many arg will be there? This is space, okay. So N2, this is the your N2 we have to find. This is the N1, this is the N2. So we can say N1 equal to 1. In first system is the SI. You will represent mass with 1 kg. But second system is the CGS. And in the CGS, you will represent mass with grams. So we can say 1 gram, okay. Then in first system, length we write as 1 meter. And here we can write, okay, 1 unit of length will be taken as 1 centimeter power 2. And in first system, time unit second, 1 second. And here also we can say 1 second power minus 2. I hope this step is clear. Using the formula I am telling now. So we can say in the first system, this is the 1 kg, this is the 1 meter, this is the 1 second. In the our CGS system, this will be the 1 gram, 1 centimeter, 1 second. Now we need to cancel this upper and lower. So you can say 1 here. Let's see how we'll cancel. 1 kg in which you are comfortable, you have to convert so that they can be cancelled. So we can say 1 kg will be 1000 gram divided by 1 gram. Here we can write 1 meter as 100 centimeter divided by 1 centimeter whole square. And here you know second already cancelled. So this value is coming here 1. Now we can say in this one Let's do this calculation. Here you can say, sir, gram is cancelled. This centimeter cancelled. So how much is left here? This is the 10 power 3 here. And this will be the 10 power 2 square. So this will be the 10 power 4. So answer becomes how much? 10 power 7. So you got value of n2 10 power 7. So you can write the answer here finally. Sir, 1 joule is equal to 10 power 7 arc. Okay. Can you remember this thing? So I have taken just very simple question, and we need to remember also this result. 1 joule equal to 10 power 7 arc. And this way we have to solve. Here we can write the dimension of that particular quantity. It can be energy here. Next I can ask force. Next I can ask anything. That particular quantity we can take here, and then we have to write the dimension. First set of dimension, then second set of dimension. First unit, second unit. And we know here first unit is the SI. Second is the CGS. I can take here this one as FPS also. Can you convert this one in the FPS system also? Foot pound second. If I ask one question on FPS, then what we can write here? Yes, mass you will write 1 pound. Here you will write this one as the 1 feet. Second will remain second. Clear? If I want to make my own system, you can also make your own system. At okay, sometimes you have seen at your okay home, everyone is having balance at home. That balance is there at home. Suppose you have to, okay, someone is asking rice to you. So, okay, how you will be taking that measurement? You have balance, or without balance also we can take the measurement. Suppose, okay, your friend is asking some, okay, some rice or something, okay, and you have to give, okay, some quantity. How you will take the measurement? Using balance or some type of jugaad? Yes. Someone is saying, sir, we have one container of glass. Yes, we can use. We can take any of the container, like you have given. Suppose, okay, 5 container rice you have to given. You have given. Okay. Later on in the same container we can take. So here without balance also we can have some exchange. So, and for you one container, you know, okay, that one container of that, okay, your utensil basically we can say it can be 5 kg. So for you 1 unit is basically 5 kg. Huh? You know, basta is there? Basta? Basta. How many kg in that basta? How many kgs? Okay, 50 kg also, 100 kg also. Okay, 50 or 100. Okay, if I am talking about big basta, okay, not the okay chinna basta, bigger, okay, big basta. Okay. So that is the 100 kg. Okay, so we can have in that multiple also. So for in that case, okay, in that case basically you can take your own system. You can make, yes, we can take 1 unit as the 100 kg. Okay, so you can make your own system also. Okay, like suppose here Nayak want to make, okay, Nayak is saying now today I will make my own system. I will not take measurement in the SI. I will not take measurement in the CGS or FPS. I am going to make. Then Nayak can refine that in my system, mass I will take, okay, mass I will take 1 basta. Okay, mass will be taken as 1 basta. Is there any problem? So we can say that yes, mass can be taken as 1 basta. So here what we can write here in this one? In this one, we can write here mass as 1 basta. He is saying distances I will take in the kilometer. Distances I will take in the kilometer. Means distances is basically 1 kilometer. So we can say in the Nayak system, this will be the 1 basta. This will be 1 kilometer. Time he is saying I will take a minute. So here we can write what? Minute. This is the one hypothetical system created by, assumed by Nayak. Okay. But when you have to convert for the conversion, then we can write here 1 basta will be how much? 1000. Means 1 basta will be 100 kg. Here we can write 1000 meter. Second will be second. So can you make hypothetical system also? Hypothetical system of units? Yes. Okay. If I give you, suppose Newton you have to convert into CGS. What will be Newton in CGS? Then you know 1 Newton is 10 power 5 dyne. 1 Newton is 10 power 5 dyne. Everyone is very well clear about this one. 1 Newton is 10 power 5 dyne. Yes. Now, what I'm saying here basically that if Newton, then in the Newton basically Newton is the quantity of this question you have written force. So in the force basically what will be the dimension here? MLT minus 2. So this power 2 will not come. So this power 2 will not come. Then we can say earlier this was the SI system. lower side, this is the CGS system, power 2 will not be there. So what will be the answer here? If you say 10 power 3 and 10 power 2, so answer will be how much? 10 power 5. 1 Newton equal to 10 power 5. Can you solve this same way? 1 Newton into dyne. Okay, you can write this homework. Convert 1 Newton into dyne. Convert 1 Newton into dyne. 1 Newton into dyne. Okay, and you can write homework. This is the homework. Okay, write one question. Find value of 10 Newton force. Value of 10 Newton force. 10 Newton force. Okay, 10 Newton force in a system of unit. In a system of unit. Now this system of unit can be hypothetical system, just like I said, Nayak is making his own system. Okay, so in a system of unit, find value of 10 Newton force in a system of unit. System of unit in which mass is, how much mass you want to take? In a system of unit in which mass is, how much you want to take? Can I take one chinna basta? 20 kg? 25 kg? 25 kg, okay. Where mass is 25 kg. 25 kg means mass we are taking as one, okay. If you take one chinna basta, it is around 25 kg, okay. Mass 25 kg. Length, how much length you want to take in this system? Length means 1 unit of length. You will take how much? 10 meter, okay. Priyanka is saying 10 meter, so we can say length 10 meter. And means 10 meter length will be taken as single unit in this new system. 10 meter will be taken as single unit, okay. And what about the time? Time, Khaja is saying 5 minutes, okay. And time 5 minutes, okay. So these values, okay, given by you, so I have taken here, okay. Now, someone is saying 1 minute, and next question I can take 1 minute, okay. Yes. Listen, what you will do, N2 equal to, you will use same thing, N1, U1 by U2. U1 means dimensions you need to write. So N1 dimension we can write here. What? MLT minus 2. Okay. We can say the dimension here MLT minus 2. But now I can say MLT minus 2. This will be the first system divided by second system. I can directly write, okay, mass with the mass. So what I can write here in this one, that N1 mass with the mass, so M1 by M2, length with the length, so L1 by L2, and here we can write T1 by T2 power minus 2. We are trying to convert here, what we are trying to convert? Force. So we have written dimension of force. If I give you this question for the pressure, suppose if I give you a question of pressure, then what you will write? Dimension of pressure. If I give you this thing, your density, then you will write dimension of density. Previous question was question of energies. We have written dimension of energy. If I give you Planck constant, you will write dimension of Planck constant. If I give you gravitational constant, then you will write the value of these dimensions of gravitational constant. And what dimensions you will write? M minus 1 L cube T minus 2. Okay. So now we can say N1. N1 is basically, this one is the 10 Newton. So we can say 10 Newton. Okay. And here we can say M1. First system is Newton. Newton indicates that first system is the SI system. And this is the your hypothetical system. So we can say mass will be taken as 1 kg. But in the new system, this is the 25 kg. We can write here. Then we can write here L1. L1 is how much? In our SI system 1 meter, but this is here 10 meter. And we can say this one time is 1 second, but now our new system is 5 minutes. We can say here 5 minute power minus 2. Okay. Now we need to cancel here. So you can say first thing, this kg and meter is cancelled. And directly I can write here, this one is 5 minutes. And you can say, sir, 5 minutes directly you can write 5 into 60 second. Why to write one extra line? So kg cancelled, meter cancelled, second cancelled. So now we can say 10 into 1 by 25 into 1 by 10 into This is 300 and 300 will go upside. So what will be this one? 300 square. 300 square I can write here. 300 into 300. I hope this one is clear. Now we can say 0, 0 cancelled here. Yes. And what will be the answer now? Answer you can say becomes 3600. And here we will use the word unit. I cannot write here Newton or something, unit, because we don't know. Okay. Here you can give some name in this system. Like we can say we have taken this one for, okay. Yes. For someone we took, you can give your own name here, 3600 unit. Clear? This question. Are you clear na? Can you solve if I give you one more question? One question like this, if I give you, ready to solve? Okay. So one question I am going to give you, see this one. But here you have to put dimension of that quantity, whatever conversion, okay, for that, like we need conversion for the energy, like dimension of energy. We need conversion for the Planck constant, okay. Sir, 300 into 300, how? Array, this is here, 5 into 60. 5 into 60 will be how much? 300. 5 into 60 will be 300. And 300 downside, power minus 2 is there. It will go upside. Surya, I have written one direct step. I hope everyone will get this thing. Most of the time I don't write this thing. Because I know that whenever I write anything, direct problem comes. So, okay, what I have written here, that this was the 10 into 1 by 25 into 1 by 10, and this was 1 by 300, power minus 2. When you will take this one upside, that will become 300 power 2, okay? Yes, Surya, clear? Everyone is very well clear about this question here. Okay, so now we'll go for next question. And next question I can give you, okay, like here, how you identified this is the SI? You identified this system is SI because of Newton was given, okay? Newton was given, so we identified this is the SI, okay? But what I will do now, I will change this. Here I will not give you Newton. I will give this one also hypothetical system. First we write the question, okay? So, value of force in system A, value of force in system A. And what is the system A? System A means set of system, okay? In system A, in which mass is, okay, mass is 2 kg. What length you want? Length, your choice. Mass 2 kg. Length, you can take for the system, okay, whatever you want here. Length, yes. 5 centimeter we can take. Someone is saying, okay. Time, what about the time? How much time you want to take? Your choice, you can take anything. There is no problem. Time. Okay, someone is saying, sir, I want to take 30 second. Okay. Time 30 second. Okay. Now, value of force in this system, okay, is 50 unit. Okay. So 50 unit, but which system basically? In system A, this is the 50 unit. Clear? Clear? In this system, this system is SI system. Is this CGS system? Is this FPS system? Or this is the hypothetical system? This is the hypothetical that we don't know. Okay. Someone has defined something. Okay. Okay. Find this. Okay. In system. Okay. Find this value in system B. And system B you need to define. What you will take? Mass. You are free to take anything. Yes. Mass. Tell some values. 10 kg. Okay, 10 kg. Next, length. What length you want to take? Length. Okay, someone is saying kilometer. Take kilometer, no problem. How many kilometer? Okay, I have taken 2 kilometer. Okay. Time. 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 Okay, 20 minutes. Someone saying 20 minutes. So 20 minutes. Okay, time 20 minutes. Okay, your choice. You can take anything. Okay, so two hypothetical system. Now we will write here N2 equal to. So you can say N2 equal to N1. Dimension. We are talking about force. So we'll write the dimension of force here. So we can say M1 by M2. Then we can write here L1 by L2. Then we can write here T1 by T2. Okay. Just you need to write the dimension for that particular quantity. It can be force, it can be energy, it can be anything. Okay. Out of the 94 listed in NCERT, any quantity they can ask. However, the question, whatever they will ask to you, that will be the very known quantity like force and energy. After that, we'll write here N1. What are the N1 basically here? There are the 50. So we can write here 50. Now, first system is A, second system is B. Just we have to put the values. So in first system, this was the 2 kg. Second system, this is the 10 kg. We can put here. Then we get L1. That is the your how much? 5 centimeter. 5 centimeter. Divided by this is the 2 kilometer. 2 kilometer. And here we can write this is the how much? 30 second divided by we can write here 20 minute. Okay. And power minus 2. Calculation I will not do. Calculation you have to do. Okay. But here we can say this one directly I can cancel kg. Other things not cancelled as of now. So no problem. I can say 2. So you can say, sir, this 0 I can cancel here. Yes. So we can say 5 into 2 will be the 10. Okay. 10. And here we need to cancel. So we can say this will be how much? 5 centimeter. 5 into 10 power 2 meter we can write. Everything we can convert into meter. And 2 kilometer 2 into 10 power 3. Okay. Meter we can write. And here we can say 30 second will remain as second divided by we get 20 and 1 minute will be 60 second power minus 2. I hope up to this conversion is clear. Yes. Just I am putting the values here. This value I have placed. Now I need to cancel here. So you can say that here 2, okay, meter cancel, second cancel. 30, this will give you 2 here. And we can say this will be 2. So this will be 5 here. Okay. So I can write here 5 into 5. That becomes 25 into. This will go upside. So 10 power minus 5. And this one. 20 into 2 is how much? 40. 40 na? And 40 square. 40 square. So 40 square, we can say 40 square here. Now we can say, let's okay, solve this thing. So I can write like this, 25 into 10 power minus 5 into 40 into 40. So we can say here that 25 into 4, that will be 100. Okay. These 20 will be cancelled. Okay. I'm writing all the steps, 100 into, okay, 100. Okay, these two into 4 into 10 power minus 5. So we can say answer becomes 0.4 unit. I hope this thing is clear. Yes. And that calculation, okay, calculation you have to do. Okay. Can we do one more question here? One more question on this. Yes. Okay, good. So now I think you are okay, confident that if they have given any known system, it can be SI, it can be CGS, or they have given any hypothetical system, then we can have this conversion. Okay. So now we'll do one more question here. Okay, add now. Sir, calculation not coming. Surya, no problem. Okay, calculation slowly. Okay. Just in the calculation, take your time. Okay, don't do all these things in the fast way. Sometimes, okay, calculation problem might be there. Do the simple way like here. Okay, I have just written. Okay, almost each step I have written here. This 25 into 400. Okay, that's why in the beginning also I said that up to 20 tables. Okay, these are not actually required. Are 0.4 is coming. 0.4 coming now. What answer? 0.4. Yes. Okay. If you have any problem in the line, You can ask first line, second line, third line, fourth line. This is the fourth line. This is the fifth line, and finally sixth line. Where problem is there? Just tell. First, second, third, fourth, fifth, sixth. If you have any problem anywhere. Okay. No, this calculation mistake will be continued. When I was in Kota, then I met one landlord, and he was doctor. So it took almost, I think, half an hour to explain that calculation of unit. That electricity unit will be there, na? Like when electricity bill is coming. So that bill was the combined bill was coming. And in that one, okay, I think, and separate meters were not there. Separate, generally we have a separate meter for all, okay. So separate meter was not there. And okay, there was one combined meter was there. So I think 3 people were using in that one. So that calculation that, okay, so what are the basically that whatever the unit, suppose, okay, 300 unit comes, then divided by 3. So each is having 100 units, and suppose each 1 unit cost is 8. So total becomes here, electricity bill of each is 800. That is a simple calculation, nothing is much. Suppose, like this was the calculation. But to explain this calculation, it took almost half an hour. Later on, I asked. Then he was having one. I asked that how you manage all the finances then. He asked that I have one accountant. Then I asked that for the accountant to cross-check accountant also you should know at least some calculations. Then he was also laughing like just like you. Yes, you can keep the accountant, but if you don't know the calculation, then okay, somewhere accountant will have the game also. To keep on eye, you should know some calculations. Calculations are the very important. Okay, so take your time in the calculation. Never have this thing. Okay, it takes half an hour, 1 hour, 2 hour, does not matter. Okay, concept should be clear that how things are calculated, how this calculation of, he was very interested to know this calculation that okay, this electricity very now we'll do one more question here. I will not go into that one. So question is here, and yes, this is the this is not a story, this is the real means all the dimensions are not explained, but it is the completely real thing. So now question is here, find 1 kg in a system of unit, in which mass means in which force is 10 Newton, velocity 5 meter per second, and time 1, or time we can say here, suppose 1 minute. Okay, now this is the question. So we need to find this question first. You need to read here. Find 1 kg in a system of unit in which force is this. Okay, so they are asking mass. 1 kg means they are talking about mass, and mass they are asking in terms of force, velocity, and time. Have you seen any question in which I have represented mass in terms of force, velocity, and time? Can I represent mass in terms of force, velocity, and time? Yes. Is it possible to represent mass in terms of force, velocity, and time? Have you seen any question like this? Anywhere in the previous classes, anywhere this question came, that force means mass in terms of force, velocity, and time? Yes, because here we need the basically relation of mass in terms of force, velocity and time, and very well you know, I have told you two methods. We can say force is basically equal to m into a, and we can say acceleration is velocity by time, so we can say v by t. So now we can say mass basically becomes here ft by v, or we can say mass will be equal to ft v minus 1, ft v minus 1. Yes, ft v minus 1. Priyanka, this is the answer. Okay, and don't remember, okay, that sometimes we remember and we remember wrong answers and we put, okay, we can solve. Okay, so now we can say mass we got, this is the dimension of mass. Okay, here they are asking mass, we need dimension of, we need to convert the mass we have to convert in, okay, terms of force, velocity and time. So we need dimension of mass. Dimension of mass is required in terms of force, velocity and time. That one we got like this. And suppose you are not able to get like this sometimes, okay, we are not getting this direct relation, then what you will do? Then we have to write power A, power B, power C, that long method was told to you, okay, that way we will do. So now we can say N2 equal to here N1, dimensions we got here, so we can say F1 by F2, okay, power 1, then we can write here T1 by T2, and then here we can write V1 by V2 power minus 1. Here we have a dimension of mass, okay, because mass conversion required, so dimension of mass was required. Now, this system, first system is kg given. What kg indicates? First system is the CGS or SI. What are the first system, CGS or SI? What kg indicates? First system is SI, kg indicates that first system is SI, and you know that here N1 is 1 kg. We can say in first system, force, what are the unit of force in the unit SI system? Unit of force in SI system is 1 Newton, 1 Newton. But in the second system, this is given how much? 10 Newtons. We can say here 10 Newton, okay? Then we can say in SI system, time is always taken 1 second, but my new system, time is how much? 1 minute. 1 minute I can write as 60 seconds, and then we can say velocity. Velocity. What is the velocity in your SI? What is the unit of velocity in the SI? You can say 1 meter per second. So we can say here 1 meter per second, but in a new system, hypothetical system, 5 meter per second, okay? Power minus 1. You can say, sir, meter per second cancelled. Here second cancelled. So we can write here Newton cancelled. So 1 into 1 by 10 into 1 by 60. And then here we can write 1 by 5 minus 1. It will go upside. So this will be 5. What will be the final answer? This calculation you will tell 1 by 120 unit. Okay. Here we can write the unit. Okay. Is it clear this question also? Here mass we have, okay, represented in terms of your force, velocity and time. So dimension of mass was required in terms of force, velocity and time. We have done that thing. First we got dimension of, okay, mass in terms of force, velocity and time. Then same way F1 by F2, T1 by T2, V1 by V2 minus 1. And how we guess the first unit, we got kg here, and you know kg is the SI. So in SI, force is the Newton, velocity is the meter per second, time is the second. Yes, I hope now you can do any question on the unit conversion. Any question on unit conversion can be done. Okay, now today you have to do practice. Now we'll write next topic here, error. Okay, very important, error. Unit dimension part over. Okay, now we'll go for error. Clear? Right, error. So next I will take here, I will write here error. Okay. Now, error. Here, first thing I will just explain here, okay, what is the meaning of precision and accuracy, okay? Can you just tell what is the meaning of precision? Means, what is the actual difference between these two words? Generally, what happens, okay, in our daily to daily life, both words we can use, okay? Like if you ask to anyone, what is the meaning of precision? They can say accurate. If you ask what is the, okay, relation between them, both are same, they will say same, okay? But as a physics student, we should know is there any difference between these two? What can be the difference that, okay, some difference will be there. If you search on Google also, they will say precision means how much accurate you are, okay, means precision basically represents accuracy, but there is some difference, okay. I will give you one example here, okay, then we'll write, okay, like you are doing some experiment And true value, suppose time period of a simple pendulum we are finding. True value, okay? True value we got 20, okay? And how you will get the true value? Basically, you will take a lot of readings. Generally, how many readings we take? Roughly, I'm asking, how many readings we take? Only one reading is enough? Whenever you will do experiment, only one is enough? Or how many roughly you have taken? Okay, you have never did the experiment, okay. But whoever did the experiment, roughly 4-5 readings we take. 4-5, okay. 4-5 readings are enough also, okay. So we take average of all those readings, that is known as true value. What is the true value? Basically, average of all the readings, okay. So suppose readings are like this, okay. I have given the readings here, okay. Like one reading is here in this one, 19.7. One reading someone got 19.9. Someone got here 20.3, okay. What do you say? These readings are close to true value or not close? Or student 1, this is the student 1, okay. Student 2 had taken the reading like this, okay. He got 15.99, okay. He got next reading H, okay, 15.98. He got 16.01, okay. He got these readings. Now, what you will say about these two students? Student number 1 is accurate or precise? You can say that here he is accurate, almost very close to true value. Very close to true value, okay? Not, okay, very close to true value. But if you say student 2 is doing work very precisely, going 15.99, then 15.98, 16.01, okay? Going up to more decimal places, okay? If you say na, that what is the difference between this reading and this reading? This reading and this reading, what will be the difference between first reading and second this reading? What difference is there between first reading and third reading? The difference is 0.02 difference is there, okay. But if I ask here, what is the difference in this one? In this one, first and last reading, you can say, sir, 0.6, okay. Here, okay, between this and this reading, 0.6 is the difference between minimum and maximum. Here, minimum and maximum difference is just 0.02. So which one is more precise here? Who is taking precise, okay, who is taking readings precisely? Student A or B? Yes? We can say even if B is not accurate, B is not getting the value accurately, okay? Maybe there is some problem with the instrument, okay? Maybe the scale he is taking, okay? Like, okay, that scale you are using, okay? That is broken. 0 to 5 part is broken. Suppose you are taking the measurement of length, suppose I say, and 0 to 5 part is broken. So here what we are getting basically? More precision. Means we can say he is accurate. But here is basically your precise. And then student third. What student third is saying? That he is taking the readings like this. 19.99. He is taking 19.98. 20.01. Now what do you say? Third student is accurate and precise. Yes, both, okay. So what will be the meaning of accuracy? Accuracy means yes, closeness between observation, means observations are very close or close to true value. What the accuracy means? Close to true value. This is the your, okay. Accuracy means close to true value. It is very close to true value, okay. It is very close to true value. This is the keyword you need to remember. And if I say what is the meaning of precision here, you can say precision means closeness with true value or closeness between observation, closeness between reading. There should not be more difference between reading. What you will say? Precision. There should be more difference between reading, or there should be between reading difference should be very less. Okay, so we can say closeness between reading. Okay, this tells, okay, closeness between observation. Okay, closeness between observation. Okay, means if closeness between observation is very, very less, it means he is more precise. He is more precise. Like in this case, you can say that these readings, whatever he is taking, they are close to true value also, as well as readings are also very close. When readings are consistent with each other, very close to each other, that reading is known as precise reading. Clear? I hope you got the meaning of precision and accuracy. Yes. He is going up to only one decimal place, but this person is going up to two decimal place. So who is more accurate? This one. If I say, suppose someone got reading like this, 19.999, 19.995, 19.996. Now who is the most precise? Then you can say this person is. Now, okay, coming. Now, voice clear, voice coming. Yes, confirm fast. Okay, so I hope you got meaning of precision as well as accuracy. This, okay, short definition you can write. Everyone is very clear about the precision and accuracy, because in daily, okay, general life, daily life, roughly we can say both are the same, but both are not exactly same. Okay. Over. If anyone is asking, can you explain what is the difference? Okay, accuracy and precision, there is some difference. Yes. Okay. Now, can we go for next? Okay, whenever you will be taking the basically measurement, okay, what will happen? There will be always some errors will be there. Okay, these error can be because of the instrumental. Okay, these can be basically because of some other. Okay, so two types we can say systematic errors are there. Instrument, some problems are there. Okay, one time you can just okay, go. Okay, what are the systematic error? Okay, I'm not going for all the definitions here. Okay, what are the systematic error? What are the instrumental error? What are the human error? Okay, zero error I will tell later on. Okay, zero error I will, okay, tell what is the meaning of zero error. So now we can say one thing comes, that is the random error. Okay, like if instrumental error is there, then you can change the instrument, then that error will be removed. Instrument, we can get the new instrument, instrumental error is over. Human error is there, you can replace that human also, human error is over. Or if any human is doing the error, okay, replace that human error is also done. Okay, random error. Random error is basically because of some random regions. Okay, random regions that even you don't know what region this error is coming. Error is coming, you are taking the measurement and still error is coming. Means these errors are due to what regions? These are due to coming because of random regions, unknown regions that we don't know. So due to unknown regions, we don't know, due to, we can say, unknown region. Okay, due to unknown region. Okay, now if these are coming due to unknown region, if you know that problem is with the instrument, you are going to change, you are going to replace. Problem with the humans, okay, either you can give the warning that yes, you have to be careful, either you can replace them, you can change. But when you don't know region, can you change? Can you, what changes you will make here? You don't know region. So can you make these errors? 0. Is it possible for you to make these errors 0? Yes or no? We can make or we can never make them 0. What do you say? We can never make these error. Yes, we can never make these error 0. Is it possible to reduce random error as 0? No, not possible, because you don't know the region. Okay, so what we can do, these can be reduced. Okay, can be reduced by, okay, like we don't know why this error is coming. I will take one time observation. I got some error, then I will take one more time observation. I will take one more time observation, one more time. Okay, like this I will take so many times observation, and then I can take average of all. So basically what will happen, that when we can take as the average value. So these can be reduced by taking more, okay, observation. Okay, by taking more observation. Okay, if I say if observation increases, then error will, if observation increases, then by taking multiple observation, more observation, then what we say, error will decrease. So what is the relation basically between this one? Inverse relation is there. More observation, okay, error will be less. Like if I take okay, if okay, like I take example, if error in one observation is x, error in one observation is x, then error in two observation doubled, and you know the relation is inverse. Observation double, error will become half, because you can say this is the, okay, observation proportional to, we can say, 1 by error. Okay, so we can say here in this one, observation double, error will become half. Okay, if I say in 2 error, okay, observation, I can say suppose 10 observation. What you will say, 10 observation. If I write here in this one 10 observation, 10 observation, then you can say 10 times, this will become 1 by 10. 5 times, okay, if I say error in 100 observation, in 100 observation, you can say in one observation x, then 100 observation means 100 times, so error will become how much? X by 100. More observation, error will be less. Okay, if I say in one observation error is x, if I take 5 observation, then error will be x by 5. Okay, I hope this thing is clear. Yes, and they will ask which of the error you can never make 0. Which of the following error you can never make 0? They have given the options: systematic error, instrumental error. Answer will be your random error. We can never make 0. I hope this part is clear here, Reden. Can you ask one more question? One more question. Okay. Now, so I will be asking one more question on this. Okay. If I ask here that if this question you have to tell correct, if error in 10 observation is y, okay, or p, error in 10 observation is p, then error in 50 observation, error in 50 observation, you can say error in 50 observation will be how much? Observation 5 times, so this will become how much? Error will be 1 by 5. Okay, you have to always go like this: how many times observation, error will be reduced by that amount. Okay, clear? Okay, now we can write next question here. So reading, okay, I'm taking time period of simple pendulum. Question here, readings for time period of simple pendulum. Okay, we are taking some reading for time period of simple pendulum. Okay, I have taken the questions like this, means readings like this: 19.8, 19.9, 5 readings I will take. Okay, we are taking 5 readings for this one: 20, 20.1 and 20.2. These are the 5 observations for the time period of simple pendulum. Okay, clear? After taking 5, this one, we need to find the true value, okay? We have to find the true value, okay? How we can find a true value? True value, you can say the true value is going to be what? Average of all observation, okay? Average of all observation is taken as true value. Average or mean of observation is taken as true value. Average or mean I can say. So now we can say that, okay, here in this one TV I can write, it will be the 19.8 plus 19.9 plus 20 plus 20.1 plus 20.2 divided by 5. So what will be the true value? Can you tell? True value. Because you know this answer, this calculation is very simple. True value will be coming here 20, okay? If you solve this one, a very simple calculation 20, okay? After this, what we will do, okay? True value is 20, okay? Then second step is find error in each observation, okay? Error in each observation. And how you will find error in each observation, okay? Here we can see that error will be equal to, okay? Error will be the difference of true value and observed value, okay? What are the error in each observation? True value and observed value. Difference I said, okay? So we can say true value we got this one. Then what are the error in this first experiment, in first reading? You can say sir 0.2. In this one, what are the error? 0.1. What are the error? 0. What are the error here? 0.1. What are the error here? 0.2. Okay, so these are the steps I am writing. First, what we do, we take the reading, then we take a true value, okay, then we find error in each observation, okay. After taking error in each observation, then we find mean error. What do you find basically here? Mean error, okay. So we can say error or mean error, or error is defined as, okay, error I can say, or we can say this one as the mean error also, okay, or we can say mean absolute error, okay. Mean error, each, how much? Average of all, 0.2 plus 0.1 plus 0 plus 0.1 plus 0.2 divided by 5. What is coming? Mean error or error? Simply I will say error, okay. Mean error or error. What will be the answer here? You can say, sir, this is the, okay, 0.6 divided by 5. So now we can say error comes how much? You can say error will be 0.12, okay. This is the error, or we can say mean error, and this is the true value, okay. After that, what you will write? You have to write the answer. And how you will write answer always, okay. Answer you have to write always like this, okay. Every time you will write answer as, okay, true value plus minus error, okay. So we can say this becomes true value 20 plus minus how much? 0.12. Is there any problem? If anywhere readings are given, can you find the answer like this? If readings are given, can you find this way? First, if readings are given, from all the readings, we have to find the true value. After taking the true value, with respect to true value, we need to find error in each, okay, each individual readings, individual observation. After that, we have to find the mean error, and then answer will be written as true value plus mean error. Clear this part? Finished? Okay, means every time, okay, everywhere you will write answer like this, and we can say this is the A plus minus delta A will be written as answer, where A will be known as true value, and this delta A is actually known as simply error, or we can say this is the absolute error. I will use this word error simply, okay. Absolute error, absolute mean error we can say, okay, or we can say mean absolute error. If I say delta A by A, so delta A by A is known as relative error, okay, relative error. And if I say delta A by A in 200, then this one is known as percentage error, okay, percentage error. So do you got here that we can write absolute error? Generally we write in the terms of absolute, but relative as well as percentage. Like in this question, if you have to find the percentage error, sometimes percentage error can be required. So what we can say, 0.12 divided by 20 into 100. So we can say into 5, and 0.12 into 5 will be how much? 0.6%. Okay, so this answer can be written like this also, 20 plus minus 0.6%. Okay, so answer can be like this, okay, in this format, or answer can be in this format in terms of percentage. So you have to express in terms of absolute as well as in terms of percentage. Can we express in terms of percentage error? This part is clear here. Clear na? Because I will take 3 minutes more. Class will be over after 3 minutes. Is it clear up to this? So if anywhere readings are given, so can we write answer in terms of absolute error as well as percentage error? Okay, very good. Okay, we can write it like this. Okay, now if I take here next thing, operations. Okay, some operations on error. First one is the addition and subtraction. Okay, addition and subtraction. Okay, listen. If I give you one quantity A equal to A plus minus delta A, and one quantity B I am giving here B plus minus delta B. Okay, you have to add. So what you can do, A plus B, basically A plus B. So A plus B directly you can add here magnitude. Okay, so we can say what will be this one, A plus B, and here plus minus will be common, so error will be delta A plus delta B. So here errors are added. Okay, if I say A minus B, okay, so A minus B means you can just you will do like this, sir, A plus minus delta A minus B. Now if minus multiplied with plus minus, minus multiplied with plus minus, minus multiplied with plus minus will remain as minus multiplied with plus minus will remain as plus minus. Are minus plus or minus plus minus, that is the same thing, na? So if you multiply minus in this plus, there will become minus, in this will become plus, and minus plus itself is the plus minus. So we can say plus minus delta B. This part is clear. So what will be the answer if you write here? Then we can say A minus B, plus minus common here. So we can say delta A plus delta B. So we can say for the difference in the A minus B plus minus delta A plus delta B. Okay. And what conclusion we can write out of this? Okay. That errors are always added. Errors are always, okay. Errors are always, okay, always additive. Okay, additive means always added. Okay, always added. Clear? Here also you will add, here also you will add. Okay, I have given example here. Okay, how you will do. Is there any problem in this one? Errors are always added. I will give you one question here. Okay, suppose if I say that okay, L equal to 30 plus minus 0.8 and B equal to 10 plus minus 0.2. What will be L plus B? Tell me answer for L plus B. What will be L plus B? Yes? You can say, sir, L plus B will be 30 plus 10 each, 40 plus minus, and errors you will add. So what you can write here? 1. This will be answer. Okay. What will be L minus B then? L minus B. Magnitude you will subtract, but error always you have to add. Magnitude subtract. So 30 minus 10, that will be the 20 plus minus 1. Okay. Errors you will never subtract. Okay. Errors always added. Okay, errors are always added. Okay, if I give you one question here from the resistance R1 equal to, suppose, okay, I have given like this. Okay, 3 plus minus 0.02, okay, ohm. R2 equal to 7 plus minus 0. Okay, 0.0, okay, 3 ohm. If series resistance, okay, right now I'm telling question of series only. Okay, only series. In next class I will tell about the parallel also. Since series, you know, R equivalent will be how much? Your R1 plus R2. So R equivalent we can say how much? 7 plus 3, 10 plus minus how much? 0.05 ohm. Okay, is it clear? Suppose if I say for the capacitance, one more question for the capacitance, C1 equal to here, okay, 30 plus minus 0.8, C2 equal to, they have given 40 plus minus 0.4, they are saying parallel. Do you remember in parallel capacitance is? In parallel capacitance is how much? C1 plus C2? C1 plus C2 na? Yes. So what we can write? Answer will be how much? 70 plus minus. What will be answer? 0. Means here we can say 8.8412. So we can say 1.2. Okay. Clear? If I say this is the L1 equal to 40 plus minus 2 and they give L2 equal to, okay, here 5 plus minus 0.5. What is the L1 minus L2? L1 minus L2. What will be the L1 minus L2? Tell fast. You can say this will be 35 plus minus 1.5. Okay. Clear? Centimeter, centimeter, centimeter. Okay. So plus and minus questions can you do? Question on plus and minus. Yes. Next class. Miss, not 1.5. Who is saying 1.5? Errors are always added. Okay, 2.5. Yes. Very good. Okay. It means now you are very, very clear about this. Plus minus we can do. In next class, I will tell about the multiplication, division, and power. Okay. Generally, question they are asking on the multiplication and power. Okay, multiplication and power. So we'll do in the next class. We'll cover. Okay. Bye. Divya ma'am class is at 3 p.m. Okay. Divya ma'am class at 3. Okay. 3 p.m. Clear? Notification. Okay. Bye. Enjoy.